Hey guys, in this video we're going to explain K-nearest neighbors or KNN. That's one of the simplest and most effective classifier algorithms, and the first classification algorithm that we're going to explain in the machine learning tutorial series. First, let's imagine a graph with three categories: red category, green category, and blue category. And we have a data point, the white dot here, uh, that we need to determine the class, and the k, which is the kn parameter here, is equal to 3. So we choose the three neighbors of this unknown data point and decide on the category of this data point based on these three neighbors. So as you can see, we have two green neighbors and only one red neighbor, and we can determine that the category of this unknown data point is green. Basically, KNN has three simple steps. In the first step, it calculates the distance of the point with all the points in the graph using Euclidean equation. Euclidean equation is simply the root of distance of the point with all the points in the graph over 2. In the next step, it sorts out the distances and select the first k nearest neighbors of the list. The low k means low bias and high variance, which is overfitting. High k means high bias and low variance, which is underfitting. And the base k controls the balance between overfitting and underfitting. So it's very important to choose k wisely. In the next step, depending on the problem, is classification or regression. We can solve the problem. In classification, we simply choose the k nearest neighbors and decide on the class of the unknown point based on these neighbors. And in the regression, we simply calculate the average of the k nearest neighbors and decide on the value of the unknown point based on the average of the neighboring data points. Now let's dive into Kaggle and solve one of the simplest competitions using the KNN classifier. The competition that I've chosen for KNN classifier is Titanic competition. In Titanic competition, we have some features of the passengers of Titanic, like their sex, their age, their family members, their passenger class, and we need to determine whether they survived or not. The first step in solving the Titanic Kaggle competition is to go into the Data tab, moving to the down of the page, and download the data set. The dataset simply includes the train data and test data, which are both in CSV format or comma-separated format. Okay, so we have our train data and test data, and there's no need to split the dataset to train and test data. They're already here and separated. I use Jupyter Notebook for coding, so you can use whatever IDE that you prefer. The first step is to import some libraries. I first import the OS library to manage my directory. I import pandas as PD, and I also import scikit-learn to import my KNN classifier. In the next step, I'm going to choose the directory based on the location where my files are downloaded. So I simply write os.chdir and I copy the directory here and paste it. Don't forget to add double backslashes because that's how Python works. The next step, I choose the train path, which is my directory, I just copy this, paste it here, and add train.csv the end of the file, the end of the file address. The next step, I choose the test as, simply copy this and change it to test. So my train data, I use pandas to read my dataset. So pd.read underline CSV, and I add train path here. And in the next step, I also choose my test data, exactly the same, pd.read CSV test as. Okay, so let's run this, and run this from 2 gives me an error. Oh, here to 3. It's a typo. Okay, let's show the first 10 rows of my train data and the first 10 rows of my test data. So train data.head 10, it shows the first 10 rows of my train data set. As you can see, I have some columns here, some features like passenger class, the sex of the passenger, the age of the passengers, the number of siblings and spouses that the passengers has, and the family relationships, which is called hardship. And the output of my machine learning model, which is whether they're survived or not. If they are not survived, which if they're dead, their category is 0, and if they survived, it's 1. Okay. And let's also show the first 10 rows of the test data. Okay. You can see the test data is has exactly the same columns as the train data. It's just a smaller data set. Okay. Now let's import our KNN classifier. So in Python, KNN classifier has built-in code or library, and we can simply import it. So we can add from sklearn that neighbors import k neighbors classifier as KNN. Okay, so I had to add k neighbors classifier as KNN. Okay, now let's write our output. What's our output is our train data and survived. Survived is our model output, and our features are, we can choose our features as our passenger class, the passenger sex, the passenger, we choose also the number of siblings and spouses, and finally we choose family relations or parts as our feature. Okay, our input or x is equal to here as the p class, the sex, the number of siblings and spouses, and family relations are categorical data. We use the one-hot encoding or dummies to change them to dummies data or zeros and ones. I invite you to read one-hot encoding or dummies. That's the efficient way to analyze the data and shift the categorical data to one-hot encoded data. In this way, the model can efficiently solve the problem. Okay, so pd.get dummies train data and features. So we're encoding the features in our train data, and our x test is equal to, again, pd.get dummies test data in features. I forgot to write this here. Features. Okay. We have an error here. Survived is here is a typo. Okay. In the next step, let's define the model is equal to KNN, and in neighbors is number of the K parameter, or number of neighbors. We can add 3 here. We can guess that 3 is a good parameter. Okay. Now let's fit our model. So model that fits X input and Y. We fit the model to our input and output. Okay. And finally, predictions. Here, let's define it as model. Okay. Predictions is model that predict X test. Okay. And prediction is done. And now let's save our output and import it to Kaggle to see our results. Okay. Output is a data frame. Okay, we make a data frame, and the first column is passenger ID, which is simply our train data that's passenger ID. See if we typed it correctly. And our second column is our output, which is survived. It's equal to predictions. Let's save it. So put to C3 and choose the name of your submission. I choose submission. Okay, and that CSV, and we don't need an index, so index equal to false. Okay, an error. Prediction, sorry, here we have a typo, and here we have a problem. Sorry, here I had to write test data. Okay. Now we have our submission here, submission.KNN.1. We go to submit prediction, browse file, choose my submission, and submit. So let's move to leaderboard and jump to leaderboard position, which is 13,000. It's not a very good rank, and the number of attendees are 15,000. So using a very simple KNN model without any modification, we're on top of lots of attendees. Thank you for watching this video, and in the next videos we're going to explain more algorithms, and we're probably going to get a better rank. Thank you.